Good night, folks. Welcome to the Land Tamer stream. Good to have everyone. We are going to do some more multicast tonight, multicast labs. This, by the way, just real quick, the wallpaper of the day is from Ponce Inlet, Florida, which is here in Central Florida, not too far. If you ever get out here, definitely, this is really cool. You can actually climb to the top of this thing and get some really good views. That's going to be our backdrop for tonight. But let me pull up the chat window and our agenda. Talk about on stream, to vlog/stream/rant. And we are going to rant tonight because the support menu is gone. The traditional, I should say. The one that we're used to, the one that we know and love. And if you saw what I kind of ranted about this a little bit on Twitter and on Instagram earlier today, but I'll show you exactly what I'm talking about. And I touched on it last night. And I don't know when this goes back to. I think it's at least 2 or 3 days, probably more. Wow, live broadcast, that's hard to compete with. But if you go to the support, so most of you remember, this is what we used to see. This right here. Now, granted, I had no love for the menu screens, as you've heard me rant about the menu screens many times. But one thing that the old format had going for it was the understanding that in the actual lab, you would have access to the products section, not the technology section, the product section. And of course, you do not have access to search. But part of the art of it was trying to figure out, and that's still there, figure out where you go to find certain things. And some of them were really obscure. I'll give you one example that I've thought of so far, and that is the BGP regex formats. So to find on the old menu, you go to products, you go to network, iOS and then XOS software. You click there. I know you probably can't see that on stream very well. You click there, and then you go to 12.2 mainline, and then you go down to configuration guides, terminal services configuration guide, and in there was documented about regex, which of course was applicable to BGP. Well, that and a number of other documents, the whole 12.4 train is gone under the new menu. Because if you go here, so you still get the all products. So if you go here to support, you can click all support, you can click all products. This is where you used to get the menu. Actually, you'd have to go more categories, view all products. It made it kind of a pain to get there, but guess what? You cannot get there anymore. So fine, we still have networking software. This would have been fine if they kept this menu and just got rid of the code for the old menu. That would have been fine. The problem with this is, if this right here is what we're going to get in the lab, the old doc CD, if this is the old doc CD, when you click here, they have now eliminated a number of different versions. Now, granted, some of these are really old and very outdated. I understand that. But still, you kept some documents out there under 12.4, for example, and they have not been updated in newer versions of the iOS documentation that I know of. Okay? So 12.4 is not here. They've got 12.2 because this, if you actually go under end of support, it jumps to these versions, 12.2 SY and SX, which I think are service provider related. So they still are under the end of support was relatively, recent. So, okay, I understand they took off everything that's no longer end of support. That's the first impression I get. But for someone who uses the documentation, the Cisco documentation, day after day after day, and for someone who is old and crotchety like me and doesn't like change anyway, I'm okay if you make a change as long as it is an improvement. Aesthetically, this is an improvement. Functionally, it is not, in my opinion, because now you have lost some of the old out of support and not yet updated documentation. Honestly, some of the older docs explain things better. I found that to be the case, and even in 15.6, which is what I'm running in Viral, I understand 15.3 is what's in the lab. Some of the older documentation did a better job, in my opinion, and there were some documents out there that have not been released in 15 that I found. Maybe I just have not looked hard enough. Okay. But darn it, it was hard enough to find it the first time, you know? And some of this is coming from the INE videos and other comments from others and router gods, things like that. That's where you find this. Well, shoot, I don't know where to find it now. Now, I can go, if I do search, which, as we all know, we're told, search is not available in the lab. So granted, for my studies, I can still find it. Hopefully this is, my goal is to not be dependent at all on any documentation when I sit for the lab. That is my goal. Realistically, my age, I probably, I might have to go find a document or two. And I'm not going to be able to search for it now. So here's 12.4 mainline. Here's the document in question I was talking about, view to configuration guides. And if you go to near the bottom, they have legacy protocols, iOS terminal services, and was it terminal services? And I have a video on, yeah, this is under terminal services. And then it might be in the appendix. Yeah, regex, here it is. So, you might get a crazy regex thing in the lab, and you might want to try to remember how to do which character did that. Granted, most of these I know. Anyway, this apparently this and other documentation will not be readily available in the lab based on my assumptions. My assumptions could be completely wrong. Anyway, rant over. Y'all have heard me rant a number of times, and I think legitimately so, in my stream about the Cisco documentation, and I will continue to do so. I poke a lot of fun at the Cisco documentation. I'm probably being unfair. Cisco has a lot of documentation they keep up with. It's a massive task. They probably have a lot of good people working on it. It's voluminous. It's highly voluminous. So anyway, Cisco, if you hear this, or it's out of love, okay? But when you hear me rant, it is out of genuine frustration, okay? So anyway, Cisco Live goodness, we've seen, we'll go to something positive now, switching from negative to positive. A lot of great stuff on social media, on Twitter, etc. Some people here in the channel have been posting some really cool stuff. And there's someone here, Demetrios, who's a longtime supporter of the channel on YouTube and here in Twitch and in Discord. Passed his written today, and I'm really happy for him. He's been studying really hard, I know, and has been helping me too in some of my studies. And now the pressure's on me. In June at Cisco Live Orlando, now I need to pass mine, and I intend to do that. But yeah, great motivation there to see what's going on. It's tempting to want to go, and it's in Barcelona. I mean, shoot, who wouldn't want to go to Barcelona, period? And to be able to go there and to go to Cisco Live is amazing. So anyway, we're happy to see people are posting about it, so that enthusiasm can rub off on us. I do have just one meat chunk today. Did not have a lot of time to look at some links. I saw that there's several new podcasts out there. I haven't even checked them out myself. Haven't had time, but there was a critical Cisco ASA, Anyconnect vulnerability. Needless to say, there are people that I work with that are patching probably right now, rolling out this patch, because it's critical and it affects a lot of ASAs. And firepower devices running Anyconnect. So anyway, you probably already heard about that, but I talked to people today that had not. So Shout out to, I think it was BC Jordo from the Network Collective. His was the first tweet I think I saw about it. Anyway, we'll move on to labs here. Multicast PIM accept register. I don't know what this is. I'm kind of stuck right now in between instructional videos because I've reviewed the INE video. We've done dense, we've done sparse, we've done troubleshooting multicast. That was a good video, by the way, troubleshooting multicast RPF failures. I've actually watched the auto RP, but there's been a couple of labs between sparse and auto RP, and that's where we're at now. So some of these we're just going to have to look up the features as we go, read about them. And one of them is PIM accept register. So I'm gonna bring up the requirements and configs, and we'll get started on this. We'll get started looking at what the lab requirements are. I keep clicking that. Stop it. Requirements are here, configs, and this is called PIM, as I mentioned, accept register. Yesterday we did the sparse mode and using an access list to limit what join messages we allow, right, through our infrastructure. So, it's probably related to something like that. But the requirements for the lab are, by the way, standard INE disclaimer. This lab we're about to do on here, this is not one I designed. It is in the workbook, which I do not show on to the public. But it is linked below. You can purchase it for $2.99 before discounts, $2.99 US, and it's a great buy. Highly recommend it. I don't show that screen. I'm just going to kind of paraphrase some of the requirements here. But if you want to do this lab yourself, definitely check that workbook out, as well as the other products they offer. We're going to enable PIM sparse mode. And today the topology is going to be routers 6 through 10. Okay, and not on DMVPN. So it's basically in a straight, for the most part, a straight line. We do have one Ethernet segment here. And what else? Do not run statically configure. Okay. R5's loopback is the RP. Okay, interesting. Configure router 5 so that only source allowed on B146 segment is R6. This might be, they might be being a little sneaky here. It almost gives the impression that you're going to have to do some sort of configuration related to this segment. I think all that means is that we're just going to be allowing router 6. Okay. Anyway. Okay, and as it says, should not affect sources on any other segments. Again, I don't know that this... So let's think about this. Let's pull up the topology, which mine is just a rendition. This is a slightly revised coloring and otherwise of the INE topology, which is linked below. But what we have here is this. All right, let's draw. Let's draw. Other guys, I am going to be reducing the size of this overlay up here. It's way too big, and I just have not gotten around to shrinking it to give us a little more space here. But we are talking about this. So we have this segment, and that's huge. Huge. We're talking about this segment. Not even that. So we're going to do this. Let me do this right here. Just this segment. And all the way to 10. Looks like sort of the old handset, huh? Okay, so what it's saying is we're going to do sparse mode. Router 5's loopback is the rendezvous point. Only source allowed in V is R6. Only source allowed. Okay, so we have the source and the destination of traffic, right? So our senders will be, it sounds like what we need to do is try to make both of these, configure them as senders, right? And let's say router 10 is a receiver. Let me make sure I have that right. Figure it so that only source allowed on this segment is router 6. I'm assuming they mean the source of multicast transmissions, multicast traffic. So that would make them senders. But we want this one to get blocked. Not blocked, allowed. So to demonstrate this, we'll have to set up a receiver, and that would likely be router 10, was what I'm thinking. So what we would do is, let me look up this feature. I'm assuming the name of the lab is the name of the command or the feature, PIM accept register. Let's just look that up and see. This was not covered in any videos that I know of. So let's use our Cisco documentation page. But we're going to go to iOS 15.6. I'm going to go command reference. IP multicast, command reference. And I'm going to say it's probably IP PIM accept register. There it is. Okay, we did accept RP. And accept RP again is what we did yesterday. So if we have this as a rendezvous point, let's change this out. Fine, whatever. So if that's our rendezvous point, who do we allow to register as a receiver? So we did that yesterday, but it sounds like the PIM accept register is also going to filter who can be a sender. So it looks like we get granular control on both sides of the rendezvous point as far as the traffic is concerned in the star comma G, which is important, right? Because first you establish your star comma G this way, your SPT, or your shared tree, I should say, this way to router 5. And then when you have a sender, no way managed to find someone. Yeah, man. Macrono. Is this what you're doing? You into networking stuff? FPGAs. I am not. What is that? FPGA, is that route switch? Or is that like service provider or Yeah, no, I'm not familiar with working with those. Oh, you're a programmer. Yeah, no, there's not really a good category for this. Gotcha, just a chip. Yeah, see, there aren't really any. There's only one other like network engineer that I know that is on Twitch, and there's no real networking community yet. One day there will be though. So we kind of he groups himself. He actually does Python programming. Possibly Macrono. What are you working on, or what can I help you with? Could take network in 2 months or so. Okay. Are you looking at Cisco certification? Yeah, 5 hours, man. Have you ready for the test? Go ahead and sign up for the exam. So yeah, I have my I've taken CCNA route switch, and I've passed the CCMP route switch, and now I'm working on the CCIE routing switching. And basically, what I'm doing is going through. I have a workbook here where I'm doing a bunch of labs, preparation for the lab exam for the CCIE routing and switching. But yeah, man, the CCNA is a great cert. That's the first one I got years ago, and there are a lot of different CCNA exams now. I'm not sure what your what your interest is in. They have security, they have wireless. Keep in mind that I'm ultra news. It's just something like CC. Okay. So CC, there's a certification guide on Cisco path. They have a path. Let me see if I can find it. There's like a little security. Okay. Yeah, so there is an expert level for security. That's what CCIE is, expert. So CCNA is associate, networking associate. NP is networking professional, and IE is internet networking expert. And they have different tracks. So for example, they're all listed here. Associate professional expert, and under each track they have CCNA cloud, collaboration, and security. Industrial, that's new. I did not know about industrial. But yeah, they're different specializations. So I'm in routing and switching. There are a lot of experts in security who started out doing routing and switching and then did security, or vice versa. They go hand in hand. A lot of them do, but yeah, man, CCNA security would be a great place to start. Where I am is down here in the expert level, routing and switching. So CCIE, the exam assumes that you could already have the knowledge to pass the professional and the associate. And on a Cisco site today. Oh yeah, man, Nightbot dropped her there, but yeah, well, that's good. Yeah, you definitely a lot of this might be over your head on this channel. But learn through osmosis, man. A lot of people play it in the background and they kind of follow what's going along. But I'd say go for the CCNA security. That'd be great. But yeah, we're working on multicasting right now. So good question. Which browser am I using? I'm using Brave. So Brave is, I forget how I found out about it, But Brave supposedly is very user friendly in terms of, it does a lot of it blocks a lot of trackers and ads and switches to HTTPS, etc. And I really like it. The problem I have on this computer is I have so many different profiles. Like I have several different logins for YouTube, for Twitter, for Instagram. And so what I did is I focused everything with Brave for my LAN Tamer account. So when I go here, it automatically logs in with that account, which is helpful because, when you got a channel like this, you're managing a lot of accounts. But yeah, I switched recently from YouTube to Twitch just because, I don't know, it just seems to be a good emerging platform for streaming. And the chat works a lot better in Twitch, I think. I might be a programmer, but I work with designing processor logic circuits. It would create 8-bit computer from a single FPGA. That's cool, man. Yeah, absolutely. Provide suggestions. Again, I'm a student. I've not passed the CCIE, so I've had a number of people. I even have had CCIEs come in here and help me out through a lab. Absolutely, give me suggestions. This, part of this is to share my experience and vlog about my experience with struggling to try to get the CCIE. But there is a little selfish where, hey, if I realize that you can help me with something, I'll probably ask you to help. Also, guys, if you're not already in the Discord channel, check it out. That's kind of a Spark or Slack group that a lot of Twitch streamers use. So Discord is like Slack for streamers on Twitch. And we've got a lot of people in there. We actually interact with labs. We share labs, tips, etc. Yeah, CCIE, it's not guaranteed you're going to get 6 figures. But, it will definitely, if you're a good CCIE and you come recommended, you can make 6 figures for sure. And that's cool about being a programmer, man. A lot of networkers are wanting to become programmers now. In fact, there's a big initiative to learn programming because networking is becoming, there are a lot more opportunities for automation that, at least in years past, there was no other choice but to do manual configurations. So yeah, we're looking to automate, and networking gear is getting smarter about being centrally controlled. And so, server admins have used scripting for a long time to varying degrees, but now scripting, especially a lot of people are using Python and Ansible. And there's another Twitch streamer, DM Fiegel. I'm going to put his channel on here. If you want to learn a combination of networking and programming, he goes on at least once a week for several hours and works on network programming projects, Python, etc. I'm actually subscribed to him. He is that's his channel. He's a CCIE, I think, twice. But yeah, definitely check out his channel. And he goes on Sundays at noon Eastern. He usually streams, and he has a Discord channel as well. I think that's on his site. But yeah, guys, happy to have you here, man. It's great. The community is, it's not just about strictly hours of study, but it's important to build the community, around learning the CCIE program. It's difficult. It's hard. It's very hard. So, but yeah, we'll do some more multicasting here. So with multicasting, we're learning about some of these controls we can have in sparse mode. The first part was generally learning how to set up this rendezvous point, how to have a router be the rendezvous point. And now, though, we're learning a few little controls. Like yesterday, the lab was about we have these join messages. Once we tell a router, okay, you're going to join this group, he sends messages to the receiver. We learned yesterday how to block join requests for specific groups. So now I think this particular feature is called PIM accept register. Is going to teach us how to block certain sources or allow certain sources to actually send multicast packets. So this is IP PIM register, and as the guide here says, to configure a candidate rendezvous point router to filter PIM register messages. Okay, use the PIM register. Why would you block sources? What are packets? Packets are so packets are bits of information segmented, sent across the wire. And what they are is there's unicast traffic and multicast traffic. So unicast is I'm sending to a single source, like www.cnn.com. That resolves to a single IP address. So that's your computer talking to a single IP address. Multicast, though, is where it's kind of like it's used a lot, excuse me, for streaming video. So if you want to send, let's say you have two computers that are turned to a certain dial, for example. Let's say they get that through some page where they learn about a certain channel number. And so instead of creating two streams, separate streams, to 2 or 10 different devices that might be, you send one packet to a group address. So you'll send to a group address here, a group address here, a single packet. And only when it gets to this router, for example, he'll know that there are 2 members of that group, then he'll send 2 copies. So multicasting is an efficiency of scale. Yeah, that's what that means. And a multicast group is identified by a special address. So if you have, address for Google, for example, so we have a single address, 74. There's a special group of IP addresses that are called multicast addresses. They're special purpose addresses. Yes, exactly. So typically the routers will, in multicast, the routers will be configured in an enterprise network, for example. If you're broadcasting let's say, the CIO is broadcasting a special message, to employees. The multicast routers will know all the clients register, and they may be running a particular application. But the switches they're connected to and the routers they're connected to will be able to identify that group, and when multicast traffic comes in, it will know who to send it to. Basically the summation of it. But there are always ways for people to attack or manipulate your network. So that's why we have these controls in place. People can do denial of service attacks. So yeah, usually you want to be very specific about the traffic that you allow on your network. So to configure a candidate RP, use this IP PIM accept register command in global mode. Okay, so we're going to use the IP PIM accept register and an access list or a route map. And it specifies an extended access list or name that defines the S, G. Okay. So the source, group. That's cool. Uses a command to prevent unauthorized sources from registering with the rendezvous point. If an unauthorized source sends a register message to the RP will immediately send back a register stop message. That's cool. I want to catch that in a packet capture. The access list or route map provided for the IP PIM accept register command should only filter on IP source addresses and IP destination. Filtering on other fields will not be effective and may cause, okay, good to know. If more complex filtering is desired, use the IP multicast boundary command. So note here, the RP is also the first top designated router for directly connected sources. It will not be filtered. This, okay, good to know. So here's an example of what we're going to do. And all right, so we're going to build an access list. And this will go on router. This goes on the rendezvous point router. This will go on router 5. And we're going to do IP access list extended. And we'll call this, in this case, B146. Except B146. And we're going to say permit IP, and the format here. Okay, so this is going to be the source address, and this will be the multicast address. They don't, in this lab, they do not give us a specific multicast address to use. Should not affect sources on any other segments, right? And that's important because router 6 could be connected on multiple segments. But specifically, we're going to want the source of the traffic is going to be this interface that we want to allow, right? So that's going to make the access list interesting. So we're going to actually need to deny. There's probably a couple ways to do this. So we're going to say, I would say we have to do 3 lines. Let's see, we might be able to do it clever. We might be able to do it with 2. The point of everything you're seeing in the chart, this is our topology. So right now I am running a network here. And I'm running all these routers in a virtual machine called Viral is the software. And this is what I'm drawing on is kind of the scope of this lab that we're working on here. And so we want to allow, this is our rendezvous point router here, router 5. He's our mediator. So what we want to do is allow, when these routers try to send traffic this way, multicast, we want to filter anything that would come from router 4 or router 1 and only allow from router 6. So we're going to do that with the access list. And as you can see here, this drawing shows the IP address scheme that is used. So on this network segment, we have 155.146.0/24. And I want to see if I can get clever with the masks here. 146. We have .1. Permit. Well, with an access list, there's an implicit deny at the end of every line. So if I did allow router 6, and that's it, guess what? There's an implicit deny everything else. So sure, that would allow router 6, but what if later we add another router here? He's going to get blocked, right? So the scope of this is allow everything, but don't allow router 1 and router 4 to send. As it says here, the only source allowed in this segment is router 6. Should not affect sources on any other segments. So I'm going to do the fourth octet here in bits for router 6 is 4, 6. Yeah, we're not going to be able to get very cute with this. So I think what we're going to have to do is permit IT 151.146.6. I think I could do host here. And then this is going to be any multicast destination. And then we're going to do deny. You know what? We could even do this a little easier. Deny IP host. Yeah, deny IP host. The binary is if you have overlapping subnets, you can create a special mask in an access list. You know, when you're trying to figure out who to deny and who to allow, that really boils down to bits, which bits you're going to allow and deny. Yeah, I have some good labs on that, actually. I'll try to link some of those here in a minute. So what we're going to do, I think, is just say deny router 1, deny router 4, and then allow everything else. Permit IP any. Yeah, that's going to be our access list. Yeah, man, this, like I said, this is expert level. So you learn a lot of those things in the associate and professional, you know. But yeah, there's a lot of stuff. But don't be intimidated. Don't be intimidated by the IE labs, because you don't have to know all this stuff for the CCNA. In fact, for Multicast, what we're working on right now, Multicast, you get a few questions on it in the professional level. I don't even think you get asked about it in the associate level, in the CCNA exam. So, all right, man, that's great. So what we're going to do here is let's configure the rest of our routers. Nice. Let's see. So we need to do our base configuration here for our multicast. We'll start with router 6 and go down the line. And interface, actually, IP multicast routing, interface GS01146, IP PIM sparse mode, and what else? Yeah, IP RP PIM. I forget that command. Shoot. Router 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to open up our terminals. And move that up. I think I'm cutting that off. IP multicast routing. Let me just run through these commands real quick. GS0 46, IP PIM sparse. And then IP PIM RP address is 150.1.5.5. Yep. So we're going to need this on each of these routers. And what else? Only source allowed. Okay. So we'll do the same for router 4. Exact same configuration. Okay, see you later, man. Stop on in anytime. And router 1. Yeah, check us out on Discord, man. And of course, we're on Twitter, Instagram, all the good stuff. Let's see, IP multicast routing. That's router 4. 641. Now let's go to router 5. And this is going to be on Jazz 0145 and interface Jazz 0158. IP PIM address, and this is where we're going to put our access list. So I think that's the most efficient way of doing that. Except V146. Yeah, I think that's the way to do it. Okay, IP PIM accept register list except V146. I wonder what scenarios they would use a route map on this. Versus, do they have an example of that? I appreciate the fact that they're saying that IP multicast boundary is for more complex. And they do give an example of an access list, but the command guide does not give an example of a route map. But interesting to use VRF. PIM route when okay. All right. So this is our PIM accept register list. And I think that's all we need for router 5. Let's move on to router, let's see, router 8. Oh, we need to put it on the loopback too. Can't forget that. IP PIM sparse mode. I always want to forget to put it on the loopback. So router 8. We're going to put it on, well, IP multicast routing and IP PIM RP address. Don't want to 5.5. Interface GI0158. Sparse mode and interface GI01108. And router 10. Is, let's see, yep, the same, GI0158. And we're going to put it on the other segment too, interface GI0110. All right, and then I'm going to register a group over here. I'm going to do a join. We're going to say IP PIM join group. And we'll say 239.0.10.10. Okay, we'll put a join down there. All right, let's configure these routers. And actually, I don't want to do the access list yet. I'm just going to comment this out. Before I do the access list, I want to just, initiate a packet capture. So I want to see this reject message. This quote-unquote cease and desist. So we'll leave that down here. And we'll go ahead and configure. We'll move him out of the way. We need a little space here. So router 6. Okay, we see that working. And then router 4. Make sure I'm not missing anything here. That looks good. Router 1, I think we did, but I'm going to put this in anyway. And router 5. Router 8. Oh, I thought I commented out the... Oh, you know what? All right, so this is interesting, guys. I put a comment here, and of course it messed that up. Yeah, I need to be more conscientious of that. The IP PIM register list is there as well. All right, that's all right. We'll come back and fix all that. 5, 6, 7, 8, router 8. What did I do wrong there? IP PIM. Oh, IP IGMP join group. Yep. 290.10.10. Okay. IGMP, different protocol. All right, so we need to come back here and fix router 5. First, we're going to take this out for now. Well, this is interesting. So I added a accept register list without actually having an access list there. So what does that do? Obviously, I am unable to join. Yeah, let's look at router 5. Show run section PIM. Is that a thing? I don't know. First time trying it. Okay. So this is here. There is no access list, so it's probably freaking out. So let's take it out. It's good to know. You could really create a problem in production if you did that, right? So this IGMP message should go out periodically. And at some point, we should get the star comma G, that group. Okay, we've got it. SJCL, sparse, L local, C is connected, J is join SPT. Okay, good. So that was not there before, right? Although I wonder... So we did PIM accept register list. This should not affect receivers. Did I not read that correctly? Because that's the command we used yesterday. To accept join or prune messages, we did the accept RP. That's join or prune messages, that's for a specified rendezvous point. And for a specific list of groups, right? This is to prevent, so this is S comma G, right? This is senders from registering. Yeah, so they're going to send a register message. Right, so I'm curious right now. Let's see if this works. We haven't put in the access list yet. And we should see, for example, if we go to router 6. Actually, just for grins, let's go to router 1. And let's ping 239.0.10.10. Okay, maybe we have something going on here. Ping 290.10.10. Repeat. Aha, okay, we have some sort of issue here. All right, let's look at router 5. Receive register. This is an interesting message, guys. Receive register from router blah, 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 for group to 150.1 is not willing to be the rendezvous point. Like, no, not going to happen. So I'm not sure exactly what we misconfigured here. We're going to find out, though. I did a show IP, show run section PIM that really didn't do anything for me. All right, what is going on here? It's under interfaces. IP multicast routing is running. IP PIM sparse mode. And we should have it on our interfaces 58, we do, and 45. And we should have defined the... Did it not catch? There's a command we're missing here. RP address. Oh, I know what I did. I was supposed to remark that one out. That's the problem. Okay. Yeah, he was like, you're asking me to be the rendezvous point, and I don't want to be the rendezvous point. No. I received a register from this router, and I am not willing. It should be willing now, though. And now we should be able to ping. It was 239.0.10.10, right? Incoming interface list, RPF, outgoing 001.10.10, yeah. And rendezvous point is 150.155. That's right. There's our replies. Okay, just took it a second. All right, so that's what we normally expect to be running. Let's put in our access list. And we're going to apply this. Someone asked me the other day, they were watching my stream. Actually, I was doing a replay earlier today. And it's running on Twitch. And I was monitoring chat. And they're like, why don't you do instead of end and dropping to the... I'll show you what I mean in a minute. It's like here, if I want to do a show run. It's like, why don't you do show run? And I don't know. I don't know. I guess I tend to... It's just a habit. I type end. I don't know. I haven't thought about that too much. Maybe that would be a little more efficient. I don't know. We'll see. But we've got our access list there. Now let's add this. And we're going to do a capture. And we're going to do a new group. We'll do a new group, and then we'll start a capture. Let's see what these packets do. So let's go to router. Let's see, where do I want to capture? I want to capture router 5. J01. Yeah, let's just capture there. And we're going to capture this, all three of these. IGMP or PIM or ICMP. Okay, so let's do a new join. Actually, let's apply this. Where did it go? except v146. What if I did that? I'm just curious. Well, we're capturing right now, so let's do it right. Show run. See, I went in and then show run. Okay, v146. All right, so we're going to put a new group here. And we're going to say interface GI00110, IP IGMP join group. Let's say 239.0.10.20. And let's go to router 6. And let's ping 239.0.10.20. Okay, all's good in the neighborhood. We should have a route here. For example, router 5, show IPM route. There's our star comma G, and here's our S comma G. So, question is, if router 1 tries to send, let's do a debug over here too. Debug IP PIM. Yes, do debug IP PIM. Bring message for 239. Okay. All right. So now let's do this new group and see what happens. Update. Yeah, I'm not sure how to. I'm looking for 290.10.20 from 146.1. Okay, it didn't work. Unless this could be a timing or processor level thing. Let's do this. Let's remove PIM protocol from router 5's. Yeah, let's go to interface chat 01146. No IP PIM sparse. Do you all. Okay, there we go. That time I did a do. And interface chat 0158. No IP PIM. Okay. Show IPM route. Clear IP. No IP multicast routing. Okay, now let's turn it back on. IP multicast routing. Interface Jazz0158, IP PIM sparse. Interface L0, IP PIM sparse. And interface Jazz01146, IP PIM sparse. Show run RP. Let's see what it says. Did I not put this? Let's just look for PIM then. Okay, show access list. Accept V146. Ah, so we do have a match here. That's a good sign. Now let's try this ping. Okay, we must have done something wrong here. Deny IP host 151.146.1. Deny IP host 151.46.4. Show IP PIM interface. Okay. Did we get a counter? Received register from 154. Invalid source registration. I think that's what we're looking for. So why are the pings working? Invalid source registration. Because 6 is the DR for that segment. But he's sending it on behalf of 146.1.290.10.20 and not willing to be RP for that. Is this an addressing thing? But no, it can't be. No. Yeah, I'm not sure how that is working. Let's look at the multicast routes, right? So let's look at router 4. Show IPM route. Yeah, this is prune. Outgoing interface list null. But if we send from router 6, those should definitely go through. Yeah, so now if we look on router 4, that says PT as well. Oh, because it's not running, probably. Let's run repeat. Show IPM route 39.0.10.20. Yeah, I don't understand why it says pruned. All right, I'm a little lost, guys. So I'm going to look at the lab key. Okay, let's see if my configuration is right. IPPM RP address. Yes, it's right. Sparse mode, that's correct. Oh, did I put it on Jazz 0145? Show IP PIM. So I'm not even sure how that's working. Yeah, how is multicast even working in this case? I mean, seriously. I wasn't talking to you, Siri. I said seriously, and then the phone went did like it wanted me to give it an instruction. I have that turned on my iPhone. IP PIM sparse. I mean, really? Tell me how that even works. Okay. So what I was missing here is interface Jazz 0145. Do you see what I mean? I mean, how would that path even function? Oh, we got a Discord comment. Hey, Macrono. And DRB. Hey, welcome guys to the Discord channel. All right, so yeah, how would that even work? If you look at the topology, if I'm sending a multicast from router 1, the only interfaces that have multicast turned on for router 1 is this interface. And for router 4, it was this interface. This was not even turned on. So how would the traffic reach router 5? And conversely, router 10? I don't get it. All right, so guys, I've heard reports that there are sometimes very unusual behaviors with multicast in these virtual environments. I've heard it about GNS3, heard about EVE-NG. So far, viral has been pretty good, except for the PIM assert lab. And multicast just went kind of crazy. I would say this is a little weird. Let me continue to look at the lab key here, because if the lab key is right and my configuration is right, but it's not working the way it's supposed to, I'm okay with that, based on what I've heard. Okay, that's correct. Now, router 5, IP access list extended. Okay, so they did it in 3 lines as well. All right. They did it in 3 lines as well. I think my way works just fine. For example, if I want to say permit IP host, I guess I could say that if there was ever another router added to this segment, this rule would be a little better. Because what they're doing is deny IP 155.1.446.0 0.0.0.255 any. See what I mean? Does the same thing. I thought about doing it that way. Either way, I'm going to count that. And then IP PIM accept register list. Yep. I've got it the same way it's in the lab here, in the lab key. So I think we're good. Yeah, and it says if we ping from router 6, it should work. Now, what they have me doing here is creating a new interface. All right, this is interesting. And again, maybe this has to do with timing. Because what they have me doing is going to router 7. It's not even on this topology. But everything has been set in multicast. Now we're going to introduce a new router. And we do need this actually to be this way. Now, no IP access list extended. And we do need to change that on router 5. So now we're going to add a 146.7. So interface GI0, 146.7, 46.7, no, GI0, 1. Incap.1Q146, IP address 151.46, that's 7. Okay, and then no shut. IP multicast routing. Ratio 0, 1, 146. Oh, let's do this. IP PIM RP address. And now interface jazz 0, 1, 146. IP PIM sparse. And for some reason they want DR changed. They want router 4 to be the DR. IP DR, IP PIM DR, priority 100. Debug IP PIM. And now if we do from router 7, if we do a ping, so brand new, ping 239.0.10.20. Here's a register stop message. Okay. All right, that makes sense. Yeah, not willing to be RP. Okay. Ah, okay. So who is registering on behalf of whom? That's why. So as long as router 6 was the DR, then the registration request would be coming from router 6. As soon as we change it to router 4, yeah, okay. Got it. I always forget about how important that DR is. So going back to our diagram, and this is good. That's why we learn. That's why we use the lab key, right? So in this scenario, as we know from the DR rules, it basically goes to highest IP address unless we manually set the DR priority. So even though router 1, for example, sends a ping, it will be sent from the segment whatever the shortest path tree, not the shared tree, but the shortest path tree to router 10, it would go this way. But the source would be router 6. In fact, that's what he would register as. Router 6 is the sender of this segment. We're going to look at those packets, but essentially what we did is we added router 7, and we said, let's make router 4 the DR. So a new registration was sent with router 7 as a sender, sent on behalf of router 4, and router 5 said, nope, not going to happen. Let's look at those packets. There's going to be a lot of packets to go through, guys. A lot of packets, but hey, towards the end, it'll help that the lab had us change to router 7 and router 4. So let's go to the end and see what those look like. Yeah, here's router 5. This is a cool lab. I like it. We're learning a lot here. I am. So let's go. Wow. Yeah, it's big. Router 7. But we want to see the join prune. Wait, that's the IGMP, or the PIM after the IGMP is sent. Let's see, this is from router 4. Group, yeah. So interestingly enough, this is later because we're getting these from router. Actually, this is router 5. Okay, membership group report. Here's router 4. Interesting. Upstream neighbor. This is a join on behalf of router 6. Let's just do PIM. Yeah, we should see, like, up until this point. Let's mark this a destination. Okay, we're going to say, I don't know why I did that. PIM and destination. Two 0 10 20. Yeah. Okay, these are registers. All right, now notice later on, after we've got this, these are all coming from router 6 because router 6 is a designated router. Then we've got one from router 7. What does that say? ICMP, protocol PIM2 register. Oh, this gets encapsulated. Look at that. Now that is interesting. That's why you always got to go into Wireshark, guys. You've got an ICMP packet encapsulated in IP, encapsulated in PIM, encapsulated in IPv4. Wow. And it says info is register. Is that the same thing here? Yeah. Now what is this? This must be the tunneling they're talking about. Okay, let's change the types here. Man, that is something else. So if we look at PIM, what are all the destination addresses? All right, most of them are the 2240013s. Oh, there's a register stop. That's why I was like 155, 145.4. Where's that coming from? Oh, that must be from, is this from this hello? DR priority 1. Okay, that's just a hello that we saw on the wire. This is interesting though. I like this. Register stop. So this is saying for this group, this is the source IP. And he's sending it to router 4. He's saying you're trying to register on behalf of router 7 You are not allowed. Register stop. PIM protocol, yeah. Nice. Denied. So where did the register come in is the question. I'll bet it's inside this, yeah. So that's interesting. This packet must, from 146.7, it must go to router 4, and then router 4 must encapsulate it. Yeah, this is ping. Very interesting, guys. Oh, here's another register stop. On behalf of router 6. We may have messed up the ACL register stop. Here's a register message. Here's a register message from router 1. Router 1 sent to router 6. Oh, he register stopped him too. And this is router 6 on behalf of router 6. I don't know, maybe we had something wrong before. These were successful registrations. Maybe that was in between. Okay. Well, we see how the feature works. Our timing may not be the best here, what we're looking at, but we see how the feature works. And I'm going to take some more time later to kind of go through this workbook. Okay, there is a caveat here at the bottom about not doing verification for router 1 and 4. Okay, so the lab was weird. Has to do with the topology. It's saying that we avoided doing verification on router 1 and 4 for the accept register. This was to avoid issues related to packets being flooded out all PIM enabled interface on these devices. This particular configuration situates the traffic being able to hit router 5 and thus being able to flow down the shared tree. So, all right. Probably not the, I don't know. The lab is acknowledging that there was no way to really verify this just using the segment with router 1 and 4, which I've been trying to do. Oh my gosh. All right. Interesting. Kind of fudged, but anyway, it worked. Well, thanks, folks. I think this is going to probably wrap it up for tonight. It's getting close to my bedtime. Got to get up early. And thank you so much for joining here in the LAN Tamer stream. Appreciate the participation in the chat, Discord. And thanks for hanging out with us. Should be back here tomorrow night if all goes well. And it looks like we're finally going to be doing, let's pull up the workbook here, or the checklist. It looks like we'll finally be getting to the auto RP. Which should be really interesting. One of the other folks in our server, IP interface brief, or Tony, he had some trouble with this in his environment. I think it's probably going to be similar to the results we saw here, but yeah, we will play with that. But thanks for tuning in, folks. And follow us on Twitter, Instagram, etc. And look forward to seeing you back here in the LAN Timber stream as soon as we can. Happy labbing, learning. Hope you get all the good bits, and have a good night.